Question number 5. Yes. It's okay. So the question is, question number 5. It is given that a charge plus q is fixed to each of three corners of a square. On the empty corner, a charge plus q is placed such that there is no net electrostatic force acting on the diagonally opposite charge. Then, which of the options is correct? The options are given as, you can consider the options here. Q is equal to minus 2q. Second one is Q is equal to minus 2 root 2q. Q is equal to minus root 2q. And fourth one is minus 4q. Capital Q is equal to minus 4. So first, let us once again look into the question. A charge plus q is fixed to each of the three corners of a square. Let us consider a square. Let us consider a square here. Okay. Yeah. So let's consider square at lambda. On this square, at three corners plus q charge is placed. Plus q, plus q, plus q, and plus q. Very nice. Any other shorting of your book? Hey guys, here. The preparing that simply shouting man. Hey guys, what about this? Right. Excuse me. The charge plus q is fixed to each of the three corners of a square, and the empty corner a charge. Okay, let us see. Yeah. So I kept the three charges here. So then the charge q, capital Q, is placed at another any some one of the corners, empty corner. Okay. On empty corner, a charge q is placed such that there is no net electrostatic force acting on the diagonally opposite charge. There is no net electrostatic force, no net electrostatic force on the diagonally opposite charge. So this is the diagonally opposite charge, right? So net force on this is zero. Net force on this is zero means usually other than this how many charges are there? You can say this three charges are there. Three charges are there. So for this force on this to be zero, what should be the value of this is the question. Let us say this is positive charge, this is positive charge. Let us say this is one, two, three. Three charges are there which are exerting the force on this. So you can say that force due to one is because this is repulsive, this will repel this in this direction, in this direction. So this will be the force F1, and because these two also positive charges, this will repel this in this direction with force F2. Got it? Yeah. And this we don't know what is the nature of this charge. Let us see. If it is positive, it will repel. It will attract. If it is negative, it will attract. But the condition is net force on this is zero. Means we have to understand that if this is one force and this is another force, the resultant of these two actually is supposed to be in this direction. Resultant, correct? But this resultant, if you take it as f resultant of 1 and 2 is f12, let us consider f12 or f3 also can consider. Okay, for the net force on this to be zero, as this force is acting here, if this is positive, the force due to this will be in the same direction, so they will add up. For the net force to be zero, the force due to this will be in opposite direction. For this force to be in opposite direction, this to be a negative charge. So, and hence the force due to this can be expressed as F due to plus Q. So now, your another point what you have to observe is, here if you observe carefully, F1 is equal to K Q1 Q2 by R square. Q1 Q2 by this is a square, all sides will have same side length. So K Q1 Q2 by A square. For and F F2. Whereas F1 is K Q1 Q2 by A square. Magnitudes of charges are same, distance is also same. So we can say that F1 is equal to F2. Let us say this is F, it is equal to what? What? K Q1 Q2 are both same. Q into Q square by distance is A, so A square. This is F. Now resultant magnitude of resultant of this two can be expressed as F12, which is equal to square root of F1 square plus F2 square plus 2 F1 F2. Is it clear? F2 F1 F2 cos theta. So here theta is angle between these two charges. It is nothing but 90. So but cos 90 is 0, because cos 90 is 0. This entire term will become 0. This entire term will become 0. So here square root of F1 square plus F2 square. But F1 equal to F2 equal to F. So F square plus F square is root 2F square. If you bring F square out, you get root 2F. This is the resultant of 1 and 2. Yes, this is the one. But for the net force on this to be 0, force due to capital Q should be, magnitude of this should be exactly equal to this. So you can say that for, for net force on, let us mark this as some, let us say this is A, B, C, D. Net force on charge at D to be 0, 0, I have to select F12, that is resultant of 1 and 2 should be magnitude of this should be equal to magnitude of force due to capital Q, right? So here F12 is root 2 into, but F is nothing but KQ by A square, K small q by small q square by A square is equal to force due to this capital Q on this is K capital Q into small q. Capital Q into small q is Q1 Q2 by distance between them. If it is what do you call A and A, diagonal distance will be root 2A. So that is root 2A whole square. Root 2A whole square is 2A square. Now to simplify, K cancel, 1Q gets cancelled, A square also gets cancelled. So from this we can obtain that this 2 if you send here, Q capital Q is equal to 2 root 2. One small q is there. So 2 root 2 to small q. But as we said that for the force to be in this direction, this should be negative charge. Negative. So we can say that implies capital Q should be equal to minus 2 root 2 into small q. Got it? So option 2, 2 will be correct one. Right? Yeah. Next. Electrical force between 2 points, this is 200 Newton, between 2 points. So if we increase 10% charge on one of the charges and decrease 10% charge on the other, then electrical force between them for the same distance becomes. So let us say, next, right? So the question is, electrical force between 2 point charges is 200 Newton. Question is, electrical force between 2 point charges is 200 Newton. If we increase 10% charge on one of the charges and decrease 10% charge on the other, then electrical force between them for the same distance becomes. Options are 198 Newton, 100 Newton, 200 Newton, 99 Newton, right? So let us check here. So let us say the force between two charges. There are initially two charges are there. Let us consider this as two different scenarios. In the first scenario, in two steps. In first step, we have two charges Q1 and Q2. Distance between them is, let us say, R. Okay. Electrical force between 2 point charges. It is not mentioned that they are identical, same. They are just mentioned two charges. Let us say the force between two charges is F is equal to K to Q1 Q2 by R square. Shruti sir is not there. Simply they are leaving the students like this. Means how much time they wasted. They are disturbing others also. Yeah. F is equal to K Q1 Q2 by R square. So initially, this is given as 200 Newton. This is equal to, let us say, 200 Newton. Let us say this is equation 1. Next, second scenario, if we increase 10% of the charge on one, let us say its charge is Q1. If you increase this means uh, so initially, let us say it is Q1 dash. Q1 dash is equal to initial charge plus 10% of the initial charge. 10% of the initial charge means 10 by 100 is 0.1. 0.1. 10%, right, of initial charge is increased. So it is, you can say, take it as 1 by 10 is 0.1 q. 0.1 q. Already it was a q1. Q1, if increased by 10% means it becomes 1.1 q1, right? Whereas another one, q1 dash, this is q1 dash, whereas q2 dash decreases by 0.1%, means initially it was q1, it decreased by 0.1 means it becomes zero point 0.9 q2 dash is equal to, so if you arrange this q1 dash here and q2 dash here, the same distance, then the question is, what is the force between them? So let us say the new force is f dash is equal to k to q1 dash into q2 dash divided by r square. So this you can write it as k to q1 dash is how much? 1.1 q1. q2 dash is 0.9 0.9 q2. So it is 0.9 q2 divided by r square. R is same. So this you can also write it as, this is equal to 1.1 into 0.9. How much? 11 into 9. 99. So 2 decimals means 0.99. 0.99 into k to q1 q2 by r square. So this is f dash. So but k q1 q2 by r square is 200. So this is f dash. So but it is equal to 0.99 into 200. 0.99 into 100, you can write it as 2 into 100. 0.99 into 100 is 99 into 2, 198. 198 Newton. This will be the new force. Alright? So you have to do that. Next. Okay. Next is okay. Right. See? Yeah. particle having a charge of 2 into 10 power minus 6 coulomb and mass of 100 ton is placed on the bottom of smooth inclined plane. The bottom of smooth inclined plane of inclination 30 degrees. The distance of another particle of the same mass and charge placed on the inclined plane so that it may remain in equilibrium is the distance of another particle of same mass and charge. Same mass and charge. So the condition for equilibrium is net force should be equal to 0. So you can say this is as per the data, it is given that a particle A having a charge of 2 microcoulomb and a mass of 100 grams is placed at the bottom of smooth inclined plane. Let us see there is a smooth inclined plane. This is a smooth inclined plane. The particle having a charge of Q 2 microcoulomb is at the bottom of, so this is a charge Q is equal to 10 to the power minus 6 coulomb, 2 microcoulomb is at the bottom of this, and it is having the mass M is equal to 100 gram is equal to 100 into 10 to the power minus 3 kilogram. Kilogram. And the angle of inclination of this is 30 degrees. Okay. Then the distance of another particle of same mass and charge placed on the incline so that the distance, where should we keep it so that it may remain in equilibrium. Somewhere we have to keep another charge on an incline at some distance, or so that it is having same, its mass is m, charge is q, of same mass and charge, so that it should be in equilibrium. So means you have to say when it is here, its mg will be acting downwards. It's of course its mg will be acting downwards by symmetry. It is making an angle theta with this. So this will be mg cos theta and this will be mg sin theta. Mg cos theta is acting in this direction, right? This is mg for this. Mg cos theta will be acting in this direction. Mg cos theta, and because these two are uh, repulsive forces, same charge, right? It means it will repel this. So because of this, a repulsive force F acts on this. Got it? So if this is the only force, it may move up, but because of this force mg cos theta, so it is pulling down, and hence when these two are equal, then you can say that net force on this will be equal to 0. It is in equilibrium means force on any of the system, any of the particles will be equal to 0. The entire system is, right? So let us say on this it is equal to 0. Okay, so that means mg cos theta will be equal to F electrostatic force. This is mg cos 30. Let us substitute the values also. The question is, what is the distance between them so that it should be in equilibrium? For what distance? So let us say m is 100 into 10 power minus 3 is 10 power minus 1 is equal to 10 to the power minus 1, right? 100 can be expressed as 10 power plus 2 minus 3, 10 power minus 1 into g is 10 into cos theta is 30. Cos 30 is equal to F is k into q1 q2 by r square, q1 q2 both are same, so it is q square by r square. We want to find out what is this r square. So r square, if you, this is 10 power minus 1, 10 power plus 1 cancel out, cos 30 is root 3 by 2. So if you bring this r square here, you can write r square is equal to numerical values they have given. Options are given as numerical values. First option 27 centimeters, second option 16 centimeters, third option 30 centimeters, fourth option 45 centimeters. So we can write this as r square is equal to k 9 into 10 to the power 9. Q is given as 2 into 10 power minus 6. Square means 4 into 10 to the power minus 12 by is root 3 by 2. Root 3 by 2. So means 2 goes here. What is this? R, right? Oh no, no, this is R. But here cos 30. Cos 30 is root 3 by 2. Okay. Now on simplifying this, further, how can you write here is approximately 4 into 2, 8. This 9 can be expressed as 3. Sorry, 3 into 3. 1 3 can be expressed as root 3 into root 3. So 3 root 3. Right? 3 root 3 into 8. 8 into 3, 8 3 is 24. 24 root 3. 24 root 3 into 10 to the power minus 3, minus 3, right? R square, r square. So is this r square only? Q square, yeah, q square is this. Now r, if you write it, we will square root of this, square root of this, right? So if you find out the value of 24 into root 3, root 3 is 1.732, right? Root 3 is 1.732, then find out what is that, 24 into 1.732. 41.6, approximately 41.6 into 10 to the power minus 3, r square equal to, so 416 into 10 to the power minus 4, so square root of 416, so square root of 416, let's say 416 root 20.3, 20.4, approximately 20.4. So r square, r is equal to 20.4 into 10 to the power, you can write it as 10 to the power minus 2 meters. So 20.4, there is no such option. 27. So any value will be more than 20. So the any of these values have, uh, one second. So 30 if we take it as 31 by 2, 3 will not come. Only this. Mm, 3 into 2, 3 into 3 into 2. So we are getting approximately nearly the first option 27, but you observe, did you miss any values here? So approximately you are getting, but not exactly. If you take G 9.8, where is G here? G 9.8. If it is a denominator decreases, its value will increase. Yes, that also you can try. So let us type. Uh, so r square is equal to, here you can write it as r square is equal to 9 into 10 to the power plus 9 into q square is 4 into 10 to the power minus 12 divided by 10 power minus 1 into 9.8. 9.8. 9.8 and 10 power minus 1 is 0.98. 98, right? Into cos 30 is root 3 by 2. Root 3 is 1.7 theta also, right? Into 2. It is equal to 9 fours, 36. 36, right? So 36 is, if you want to express this further, it is 0.98 into root 3 is 1.732, and this will be 36 into 2, 70, 72 into 10 to the power minus 3. So in simplifying this further, 0.98 into 1.732, 0.98 into 1.732, 1.67 is right. So 72 divided by this. 72 divided by 1.6, 1.7, let us say. 1.7. 72 divided by 1.7 is 42 point this. Square root of this 6 point. Oh, okay. So I have 10 power minus 3 is there, right? So I have to write it as for 423. For 423, I have to take the root. For 423, 423 or 424, square root will be around this only. I am getting 416 to 423. Some parameter is approximately we are getting. Okay, let's check it. Let's check it. So approximately we are getting this one centimeters. So it can be expressed as approximately 20.4 centimeters. Right? And check, cross check. Once again, any parameter we are missing. Actually, by symmetry, this is theta, right? Okay. Then this is theta. This is 90. This will be 90 minus theta, right? This is vertical. This one. Hmm? So, so if you consider, I think this will be theta then, right? In mg cos, this will be mg sin theta. This is theta. This will be theta under the vertical, and this. If you see, this is vertical, and this is theta, and this also theta. 90 minus theta. This is 9. This will be 60. So with vertical and this side one. So this is 90. Okay, this is 30. This is horizontal, and this is horizontal, and this incline. This incline is, let us try to do, I think some the angles we have taken wrongly. You see here, this is the incline, this is horizontal, this is 30, right? So we are having this is the one, and so this is actually here, this is normal, this is mg. So this is vertical, this is horizontal, right? This will be normal to this. So this is 30 minutes, this will be 60. This is 60 minutes, this will be 30. As this is total is 90, this will be 30. With what and what? With this one and the mg, this is your 30. Actually, this is cos theta. This is not this one. This will be cos theta. This will be theta. So then this will be mg cos theta. Then this will be mg sin theta. This will be mg sin theta. If mg sin theta, if we equate mg sin theta is equal to, in place of this, just simply if you represent in place of root 3 by 2, 1 by 2. Root 3 is not there, 1 by 2 only. 1 by 2 if you replace, then what you will get? So it gives sin theta, right? It is equal to fe. Then here, then these calculations, here itself directly if you substitute, if root 3 is not there, 9 into 4 into 2, 72, right? 72 r square equal to 72 into 10 power minus 3. Or you can write 7.2 into 10 power minus 2. You want 10 power minus 4. 720 into 10 power minus 4. So you can write it as r square is equal to 720 into 10 to the power minus 4. So 720. 720 under root 26.8. Yes, but you have taken it wrongly. So r is equal to 26.8 or 27 approximately. 27 into 10 to the power minus 2 meter, it is equal to 27 centimeters. This we did wrongly. Okay, this will be sin theta. This will be not cos theta, this will be sin theta. mg sin theta. mg sin theta. Here, this is not clear. From here onwards, all these things have to change. Right. So it is equal to mg sin theta is 30. So here it is, this gets cancelled. So you'll get r square. If we bring it here, it will be mg sin 30. And simplifying this, right, r square is equal to 720 10 to the power minus 4. You will get r is equal to 26.8 into 10 to the power minus 2 meters. So r is equal to 27 centimeters. This one. Question is, right, here 36. The question is, three charges minus q plus q minus q are placed at the corners of an equilateral triangle of side A. The resultant electric force on a charge plus q placed at the centroid O of the triangle is. Three charges minus q plus q minus q are placed at the corners of an equilateral triangle of side A. The resultant electric force on the charge plus q placed at the centroid of the triangle is. So let us consider. This is equilateral triangle. This is equilateral triangle. Three charges minus q plus q and minus q are placed at the vertices of this. Let us consider this is A, B, and C. Of side length A, BA, and A. Then the resultant electric force on a charge A plus q placed at the centroid. Centroid is nothing but point of intersection of medians. This is one median. This is another median. Right. This is another median. The point of intersection of these medians is called centroid. Right. So here you have kept one more positive charge plus q. Plus q is present in the centroid. So what is the total force on this? So other than this, how many forces and charges are there? 1, 2, 3. So force due to this, force due to this, force due to this. Consider and find the vector sum of this. So let us say this is first charge. This is second charge. Let us say this is B. This is C. Second charge. This is third charge. So let us call the force due to the this is 1 F1. It is a negative charge. This is positive charge. So this will attract this. So let us mark this as force due to this will go in this direction. Let's say this is F1, right? And force due to this is negative. This is positive. This also will move this direction. Let us call this as F2. and this is a positive, this is positive, this will repel this in this direction. So let us say this is F3. And one more point what you can understand here is this F1, F2, F3. F1 is Q1, Q2 by this distance square. Q1, Q2 by this distance square. This is Q1, Q2 by this distance square. But Q1, Q2 both are having same magnitude here and here and here. Magnitude is same. Then what about this distance? This distance. You have to understand that this this distance will be equal for from every vertex it will be equal same. To understand to find this, let us consider this angle is, if this is a equilateral triangle, this total angle, the angle between these two sides is this is 60, so this will be half of it, 30. So here similarly here 60, here it should be 30, here also like same way you have to consider. Now only let us consider this point. If this is our distance r, we want to find this. So in terms of known parameter a, if this is total is a, this will be half of it. So this will be a by 2 from here to here. So if you find the cos theta from this figure, cos theta here is cos 30 is equal to, if you consider this and this is like a, this is g, right? This is some rho. A rho G is a right angle triangle. For this, cos theta equal to adjacent side by hypotenuse. Adjacent side is A O. It is nothing but A by 2. Adjacent side is A by 2. By hypotenuse is our R. We want R. From this we can say R is equal to, we bring it here, A by 2 by cos 30. A by 2 by cos 30. Right? So from this we can also say R is equal to A by 2 into cos 30 is root 3 by 2, 2 cancel, later is A by root 3. So R is equal to A by root 3 is our R. Got it? Now R is same for all. A by root 3, A by root 3, A by root 3. Now let us say F1 is equal, so is as fixed. Magnitudes of charges are fixed, R is also fixed. Means we can say F1 is equal to F2 is equal to F3. Let's say this is equal to F. This is equal to K Q1 Q2 by R square. K Q1 Q2 are same Q, so Q square by R square means this whole square. That is A by root 3 whole square. So it is A square. A by root 3 whole square is A by 3. A square by 3. 3 goes to here to numerator. So you can write this as 3 K Q square by A square. 3 K Q square by A square. Right? So this is your F. This is 3 K Q square by A square. Now, what is this? Every force is the same. But you can say as this is F1, this is F2, this is F3. Resultant of F1 and F2 should be F1 and F2. So resultant of these two, you can understand that it will be in this direction. It will be in this direction. Got it? And that resultant and this will add up. Right? F1 2. Right? Let us say resultant of 1 and 2 is F1 2. And this will add up with F3. Right? So let us say the final total force acting is equal to resultant of 1 and 2 plus F3. Got it? It is equal to resultant of 1 and 2 is nothing but what? If to find here, let us say it separately. Resultant of 1 and 2 is equal to square root of F1 square plus F2 square plus 2 F1 F2 cos theta, right? It is equal to square root of F1 is equal to F, F2 is also equal to F. So F, right, so you can write it as F square plus F square plus 2 into F is F square. And the theta is here how much is another question. This is 30, this is 30, this is also 30. So for the sum of the three angles in a triangle to be 180, this will be 120. So we have to take this as cos 120. But cos 120 is how much? Minus 1 by 2. So if we take this as square root of F square plus F square plus 2F square into minus 1 by 2. This 2 gets cancelled. You get minus f square. This is minus f square cancel. Only one f square remains. So resultant of 1 and 2 is nothing but root of f square is f only. So here you can place f12 plus f3 is also f is equal to, is it f only? So it is equal to f, right? So resultant force is equal to 2 into, what is f? This is equal to 3 into k q square by a square. So 6k q square by a square. If options are given in terms of k only, if they are given in terms of 4 pi epsilon naught form, you have to substitute this as 6 2 into, you can write 2 into 3. Here k is 1 by 4 pi epsilon naught into q square by a square. This is a square. Okay, so this further you can simplify. 2 times, it is equal to 3 q square by 2 pi epsilon naught a square is the resultant force, right? 3q square by 2 pi epsilon naught a square. Here in the key it is given as option 3, that is q square by 2 pi epsilon naught a square. That is wrong. This is the correct one. Key is wrong, right? Try to make a note of it. Yeah. The proton of mass m charge E is released from rest in uniform electric field of strength E. The time taken by it to travel a distance d in the field is. Yeah. Once again. Right. See, question number 12. The proton of mass m charge E is released from rest in a uniform electric field of strength E. Time taken by to travel a distance d in the field is. Right. Let us consider field. There is a uniform field of strength E. There is a uniform field. This is a, you can consider this is uniform field, electric field. In this electric field, uniform field can be represented with equidistant lines. This a proton, a charge is a proton. So its charge will be equal to E. Charge of proton is E. The proton of charge E and mass m is released from rest. Means initial velocity is 0. If it is released from rest, yeah, it is released from rest in uniform electric field of strength E. The strength of the electric field is E. The time taken by it to travel a distance d. What is the time taken by it to travel a distance s is equal to d is the question. Okay, in this field. So what you have to consider here is that you have to consider the concept of motion of charged particle in uniform electric field. Got it? Uniform electric field. If you simply if you release it, that means if you leave a charge here, a charge positive charge, and this because of the field, a force acts on it in this direction, and the force acting on a charge in electric field is F is equal to, from definition of electric field we have discussed that E is equal to F by Q, right? As E is equal to force per unit charge, F by Q. So from this F is equal to QE. F is equal to QE. That means if you keep a charge Q in electric field E, a force of Q into E, that strength of the field at that point will act on this. So in this uniform field of E acts is there. So force acting on this is nothing but QE. QE force acts on it. As we know, force, this is force, but also as force equal to mass into acceleration. Mass into acceleration. That means it will be accelerating from rest. Accelerating from rest means it will be moving with some increasing velocity. Increasing velocity, but in which direction? So this is a positive charge. Force on the positive charge will be say in the same direction as that of the electric field. The same, so because of this is the direction of force horizontally, it moves in the same direction in straight line path. So we can say that. You can say as it is what we are asked to find what is the time taken to travel a distance dr. So as here a distance traveled, because it is moving under accelerated motion, distance traveled is it is moving into uniform under uniform electric field means it's uniform force. Force is uniform means acceleration is also uniform. So you can consider this as uniformly accelerated motion. So the equations of motion which we have studied in mechanics can be applied here. What are those equations? The first equation is V is equal to U plus AT, and second equation is S is equal to UT plus half AT square, and third one is V square is equal to U square plus 2AS. They are applicable here also. So the question here is what is the distance traveled in time, what is the time taken to travel this distance d. So time taken to travel distance d, if we take, let us take here S is d, distance d. The initial velocity is 0, so you can take the distance S is equal to ut plus from equation, from S equal to ut plus of at square, and say S is d. To travel this distance with the initial velocity is 0, how much time it takes? It is equal to half into at square. This is the time. We have to find this. But here what is acceleration? When force is equal to QE, the vector form, magnitude you can write it as 1 implies 1 implies F is equal to QE magnitude, but also no, 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 no. Sir, class బాధ్యత మాట్లాడడం వేరే right. So you can say also from Newton's second law, force is equal to mass times acceleration. So this is one, this is two. From if you equate this two, if you equate this two, we can say QE QE is equal to QE is equal to MA. So from this acceleration A is equal to QE by M, right? QE by M. So this A if you substitute here, then we'll get, are you following this step by step clearly? If you substitute it here, then you'll get D is equal to half into A is QE by M into T square. We want T. So let us write T square equal to, let's send this here, then it will become 2MD 2MD by QE is equal to T square. So this further you can write it as T is equal to, what are these options? Uh, the charge, it is a proton, it is given, right? So charge of proton is E. So this also can be replaced, Q can replace with the E. So T is equal to square root of 2 mass of proton is given as M only. So M 2M into D by E. E. So 2 dm by E. Capital E, small e. 12th one. 2, right? So this is the time taken. Okay, so question number 12, right? Page number 36. Yeah. This one.
Seventh question. Doubt.
One minute. Right. Next. So 9:30. So then we have to spend some time with other students, 11th students as well. So question number 138. Hmm? So the question is, a charge capital Q is divided into two parts, Q1 and Q2, such that they experience maximum force of repulsion when separated by certain distance. The ratio of capital Q, small q1 and q2 is okay. Force will be maximum when dF by dq is equal to 0. dF by dq is equal to 0. We have to take one part as q minus q1, another part, if one part is q1, another part should be q minus q1. We take those two and differentiate with q. Then apply the condition of dF by dq is equal to 0. Then we will get the condition. Okay, try this way. We will just go through once again. 1 minute, 1 minute.